set up.
Okay.
Ready?
Go.
Okay, so we're talking about cation exchange capacity and how stupid that name is. So, first off, we're just going to look at the top here with the blues, the reds, and the greens. We're going to say this is my clay here. You can see a little line there. I don't know if it's in the video. And then this is the fluid here. You can see these are against the clay. We'll get to that in a second. First, we need to understand the charges on each of these. So I've made the calcium here green. So that's a charge of +2. I've made the sodium blue. That's a charge of +1. And then I've made chlorine red, and that's a charge of -1. So in the clay, as you can see, we have some ions here that are just random. It doesn't really matter what's here. We're just going to count up the net charge here. So you see these two are a pair. It's a +1 and a -1, a +1 and a -1. But you see you have these two that aren't paired. So our net charge, our total available charge in this is a cubic meter, or it's just any volume. But in this case, it's a cubic meter.
I suggest you should take those 3 blues out of the...
Sure.
Okay, the reaction first.
Yeah,
so
we've got a little bit of thing.
And don't worry about this.
Yeah, this isn't here yet. So in here, we've got a net charge, a total available charge, which is what I call it, of 2 negatives, right? Because we have 4 chlorines, which are negative, and 2 positive sodiums. So we know that the surface of the clay in this volume has a net available charge of 2. So that's what QV is. It's a net available charge per volume. And I think QV bar, we decided, was a net available charge per mass, or kilograms. So what happens here is, because this has a net charge, you have 2 blues that show up they get sucked out of solution, and they sit there. Now we could have 1 green there. It doesn't matter. We'll get to that later.
What do you mean with having 1 green there? Instead of the 2 blues?
Sure. Instead of 2 blues, we could have 1 green because they have the equivalent charge. Right? Because this is 2 times +1 each, and this is 1 + 2. They're the same.
That makes sense.
Anyway, so we have these two, and now we can see that this is why it's called a cation exchange capacity. Is it has the capacity to take in, or if it had to already, it could exchange, right? A net charge of 2 in this case, in my very simplified model. So that is cation exchange capacity, or QV.
Great.
So we want to end there.